Hello everyone. Today we are going to explain the third problem of Leetcode Weekly Contest 380, which is maximum number that sum of the prices is less than or equal to k. So what is the problem? We are given an integer k and an integer x. Now consider s is the one index binary representation of the integer num. The price of the number num is the number of I such that I modulo x equals to 0 and si is a set bit. So we have to return the greatest integer num such that the sum of prices of all numbers from 1 to n 1 to num is less than or equals to k. So let's take the first example only where k equals to mm, k equals to 9 and our what x equals to 1. So what we have to take all the numbers in their binary representation. So let me write them: 1 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Let's take up to 7 because our answer is 6, so I am taking up to 7, right? So now what the problem defines, so we have to now another important thing is that for the binary representation of a number will be indexed from right to left. So that is one important thing you have to observe, is that the index will be from right to left. So this is the first index and it is also one best index. So this is the first index, this is the second index, this is the third index, right? I hope you got it. Now here x value is 1, so the problem becomes we have to count total number of set bits because x is 1. So we have to count the number of set bits. Here it is 1 2 3 4 5 6 7 8 9 10 11 12. So here you can see that at 6 we are getting the price as 9, but at 7 we are getting our price as 12. So our answer will be 6 because we have to take maximum value of number such that the prices of all numbers from 1 to num is less than or equals to k. So our answer will be 6 here. Now the problem will become interesting when we change the value of x to from 1 to something else. So let's take this as 2. Okay, now instead of taking k as 9, let's take the second example as k as 7, right? Let us take k as 7. Now we have to check every even bit here, right? So here the index of this one will be 1, so we can't take this as in the price, right? Here the index of this 1 is 2 because the index of this 0 is 1 and the index of this one is 2, so we can take this as our price, so our price will be 1. Now here the index of this one is 1, so we can't take it, we can take this, so our price value will be incremented. Now index of this one is 3, so we can't take this. The index of this one is also 3, so we can't take this. So index of this one is 2, so we can take this. So after doing all things like iterating over the rest of the numbers, you can check the output will be 9. So instead of doing this, let me take the rest of the two numbers also, 1000 and 1001. Now here, sorry, so here the index of this one is 4, so we can take this, so plus 1 4. Now index of this one is this is 2, so we can take this, so it will be plus 2. So this is 6 here, so when we take now 10 will have two set bits, the second set bit and fourth set bit, but 6 plus 2 will be 8, but our k value is 7, so our answer will be 9 here, right? So our answer will be 9, so you can check that our answer is 9. So I hope you got what the problem says. Now I will try to solve the problem. This problem is kind of constructive, you can say. So this does not involve that like some crazy algorithms, but this will involve some observations and some constructive thinking, right? So let's for solving this problem we have to write some numbers in their binary form, and we can use some padding of zeros. So let me pad with 3 zeros for 1. Let me write this. So I have written all the numbers from 0 to 10, right? So here you have to observe some patterns, like the first bit is occurring like 1 in twice, right? So it will be 0 1 0 1, like there is a pattern 0 1 0 1. Now for the second bit, the pattern will be 0 0 1 1 0 0 1 1, and for the third bit it is 4 zeros 4 ones, and for the fourth bit it is 8 zeros 8 ones. So that is the pattern you have to observe. Now let me explain that what will be our algorithm. Now you can check the what is our k value. K is the total price. So and when we are increasing the value of nums, the price is increasing, right? So for when we increase the value of num, when num is increasing, the price is also increasing. When num is decreasing, price is also decreasing. So this is some monotonous function, right? Monotonically increasing function, the price. So we can do some kind of binary search here, right? So in which value we are doing binary search? We are doing binary search on the price value, right? So sorry, we are doing the binary search on the nums value, right? So we'll take the what will be the minimum value of num. The minimum value of num is 1, and the what is the maximum value of num? The maximum value of num will be 10 to the power 18, because it will fit in our long, right? So minimum value of num is 1 and maximum value of num is 10 to the power 18. Now we'll do binary search on this range, and for every mid we'll try to find its price. Now if let's call it as p mid. Now if p mid is greater than k, we will try to check in our left range. So our L will be mid minus 1, mid minus 1. Now if it is pm is less than equals to k, we will set it out as our answer. So our answer will be mid, and we will check in our right range. So r will be mid plus 1. So I hope you got the binary search part. Now how we are getting the pm? So let's consider this as a function of mid. So we'll try to define this function of mid, and that is the most interesting part of the problem. The rest of the binary search is quite trivial. So how we are finding the fm, right? So we will try to iterate over all the indexes, all the bits you can see. And we'll try to find the number of set bits in every bit index. So for the first bit, you can see the pattern is 0 1 0 1. So now you can observe that if there are 10 integers from 0 to 10, we'll just take 10 by 2. We'll just take 10 by 2 for the first index. Now for the second index, if there are 10 integers, so what we can take? We can take 10 by 4. What is the number of groups? It will be 10 by 4, and we'll multiply it by 2, because in each group there are two ones. So from 0 to mid, we will try to find the number of ones groups, and we'll multiply it by the number of ones in the group. So let's say we are at some index I. So we are at some index I, then the number of ones in the group will be pw of I, power of I. Power of I is nothing but 2 to the power I, right? So for in each group we will have power of I number of ones, right? So in the second group we have 2 to the power 1 number of ones in each group, and the rest part is we have to find the number of groups, right? So here you can see that if the bit in our mid, like the last integer, if it is 0, then we don't care about this. But if it is 1, then we have to add something else, because let's say here are 10 integers, right? From 0 to 10 there are 11 integers. So we have found 11 by 4, there will be 11 by 4. If we take the floor value, there will be two groups, and in each group there are two ones, right? So 2 into 2 4. So this is the first group, this is the first group, and this is the second group. There are four ones. Now we are neglecting this one, right? This is the last group, and we are neglecting this one. So if the bit is set in the last integer, or you can say mid, if it is set in the mid, we have to take this as mid. We have to take this modulo 2 to the power I. Okay. So sorry, this is not 2i, it is 2 to the power I. You have to take it modulo 2 to the power I. So let me go through the algorithm once more. So we are explaining the fm function, how we are for a certain value mid, how we are finding the total price from 1 to mid. That's what we are doing here. So for every bit from 0 to max bit means the maximum bit which is set in mid. So for every bit from 0 to mid, we are trying to find the price of the certain bit, the number of set bits in the particular bit. So for that, what we are doing, we are taking mid by 2 to the power I plus 1. Mid by 2 to the power I plus 1 will be our number of groups. Okay, so 11 by 2 square, 11 by 2 square is what, our number of groups. So we have two groups, and each group will have 2 to the power I number of ones. Okay, in each group we will have 2 to the power I number of ones, right? So 2 to the power 1 number of ones. So this is the problem, this is the number of groups mid by 2 to the power I plus 1, and in each group we have 2 to the power I number of ones. Now for the last case, if the ith bit is set in mid, we will take mid modulo 2 to the power I to get the number of ones in the last group. So let's go into the code. So here we are calculating the power of I. Instead of doing 2 to the power I in the loop, that will be order of log n. So we are just pre-calculating the power of i's. Now we are also finding max of bit, and for every bit 0 comma max bit plus 1, we are iterating over the certain bit. If it is not I plus 1 modulo x is not 0, because you have to take only the bits where I modulo x is 0, and also you have to consider one based indexing. That's what I have done here. I plus 1 will convert it to one based indexing. If it is not equals to 0, we are just doing continue. Else we are finding mid plus 1 divided by power of I plus 1 to find the number of groups, and we are multiplying it by number of ones in each group, 2 to the power I. That I have already explained. Now if the ith bit is set in mid, we'll do mid plus 1 modulo power of I. That's what I have explained for the last group, number of ones in the last group. And if c is greater than k, we'll just check in our left range, and if it is less than equals to k, we'll check in our right range, and at the end we are returning the answer. So the problem is not very hard, but you have to observe something and construct some algorithms. I hope you got my explanation. I will also provide the link of the code in the description box. If you find this video helpful, please like the video and subscribe to my channel. Thank you.